When dealing with sets of values, it is often necessary to consider all the different ways these unique values can be grouped or arranged in a certain order. A way to do this is through the use of permutations. In discrete math, a permutation is described as a set of distinct objects and the possible ways that they can be organized or arranged, where the order of these values matters. For example, from a set of 3 alphabet letters, A, B, and C, there are 6 ways to arrange those values in order. Namely, ABC, ACB, BAC, BCA, CAB, and CBA. The mathematical formula used to calculate how many permutations are possible involving all the elements in a set with n values is simply n factorial, or in this case, 3 factorial, which means 3 times 2 times 1, equaling 6. Let's consider another example that involves a race with 8 swimmers. The top 3 swimmers will receive gold, silver, and bronze medals in that order. An important question that might come up is this: in how many different ways can the gold, silver, and bronze medals be awarded at the end of the race? To answer this, the permutation process is the right tool for the job. Since all swimmers theoretically have an equal chance of winning any of the medals, let's work out the math that calculates all of these possibilities. There are 8 different ways the gold medal can be awarded. For each of those 8 ways, there are now only 7 ways that silver can be won, since one person has already won the gold. After that, only 6 swimmers remain that could win the bronze. The mathematical expression to calculate all the possibilities is 8 times 7 times 6, which means that there are 336 different possible orders or permutations of awarding the medals in this race. Let us take a closer look at a structure for this mathematical calculation. For any given situation, to calculate all possible permutations, we first calculate all of the possible orders of finish among all 8 swimmers, which is 8 factorial, or 40,320 permutations. Since we are only interested in the finish of the top 3 out of 8 swimmers, we need to eliminate the number of permutations for the remaining 5 swimmers, which would be 5 factorial or 120. To proceed to the final answer, we divide 8 factorial by 5 factorial, which produces the correct answer, 336. Here's the expression in expanded form. Matching numerator and denominator values are then cancelled to simplify it. This results in the expression 8 times 7 times 6 equal to 336, the calculation we examined at the beginning of the lesson. This general permutation formula works for any situation where the value n represents the total number of items in the set and the variable I represents the number of items that we want to pick in a certain order. In short, n taking I. In our swimming race example, we used 8 for n, the total number of swimmers, and 3 for I, the number of medals, which gives us the total number of different orders of finish, gold, silver, bronze.